Welcome to part 2 of thermal spray deposition technique. So, in this particular talk we will discuss about different thermal spray deposition techniques in brief. So, as I mentioned you, there are a wide varieties of thermal spray deposition techniques available, and these classifications are based on the kind of heat source you are using for spraying operation and other parameters like velocity parameters, then maybe the speed of the coating. So, these few parameters are very important to dictate the different or maybe they act as the driving force or genesis for the classification. So, among these all processes you can say that flame spraying is the earliest and also you can say that most primitive in nature, and also it is quite cheap. So, in flame spray deposition process what you do is that people do use the oxyacetylene fuel as a source of heat, as a fuel for generating the flame, and subsequently is the source of heat. So, ignition of oxyacetylene flame is done in flame spraying process. So, this technique can use the material or precursor powder in the form of rod, or it can also use in the form of powder, or it can use in the form of wire. So, depending on the shape of the precursor powder, you have different kinds of nozzle, you have to design the nozzle accordingly. So, if your precursor coating, if your precursor is in the form of rod, then naturally you have one kind of nozzle where there is chance of where there is a possibility of inserting the tube continuously, and subsequently it gets impinged in that it gets inserted in the tip of the flame and gets melted, and subsequently through other part of the nozzle there is a flow of the gaseous species. Usually there you flow air, or maybe you can also flow argon or nitrogen as carrier gas, and that carrier gas is used to to just fragment the molten material into smaller droplets, and subsequently it is propelled onto the surface of the substrate to get the desired coating. It can also be in the form of powder. When it is in the form of powder, then there has to be the powder feeding nozzle, powder feeding. Through the powder feeder you basically feed the powder with carrier gas may be argon, and then what you do is that you feed it, and then that feed powder is actually flown into the tip of the this particular flame, and then that flame is actually melts the powder, and then subsequently the molten powder is again just broken into small droplets with the help of the air gaseous high velocity air and air, or maybe argon or maybe nitrogen, any gaseous species you use, and then it is propelled at a very high velocity onto the surface of the substrate. So, in this case there has to be provision of powder feeder so that you get the powders get fed properly into the into the flame tip. Here again you should have provision for the ceramic wire, or maybe that typical rod to get into and subsequently get melted, and molten material is subsequently sprayed over the surface of the substrate. So, in this flame spraying operation your main parameters will be the oxygen to acetylene ratio or maybe oxygen to propane ratio, whatever powder, whatever fuel you are using for heat generation. Your another parameter is powder particle size as well as shape, and also in which form you are using the coating material, whether it is in the form of the rod or it is in the form of wire. So, third parameter is the velocity at which it is sprayed over the surface of the substrate. So, these are three important coating parameters which play a very important role in determining the quality of the coating. And final parameter is the substrate pretreatment, what kind of pretreatment has been done on the surface, and distance between the nozzle to that of substrate. So, these are 4-5 important parameters which control the quality of the coating which you are looking for. Now, in this particular flame spraying process you will, as I mentioned you, this process is very much cheap in nature and versatile in nature, but can be applied for the coating of the low melting material particularly that your aluminum, zinc, tin and steel, few steel, but it cannot be applied for deposition of high melting point material like molybdenum, titanium or maybe the carbides, nitride, aluminides or oxides. So, those coatings cannot be achieved by flame spraying process, but can be applied for the deposition of the particularly metallic material and particularly low melting materials. And another disadvantage of this particular process is that after this flame spraying operation you end up with a porosity as high as 8 to 9%. So, large numbers of porosities or large numbers of inclusions are also present in the structure. So, it does not give the typical flawless coating, and immediately after flame spraying you need to do sealing operation, so that the coating is sealed and there is no chance of corrosion if you are interested to develop the coating by for corrosion resistance application by flame spraying. Then second type of coating is arc spraying. So, in arc spraying, as I mentioned you that it is you are using arc as source of heat. So, here usually people do use people do usually use the arc which is consumable out of the consumable wire. So, you have the DC power supply unit and two wire you feed, and then at the contact point you have the arc generation, and that arc generation is capable of melting this particular tubes or maybe wires, and subsequently you basically use the compressed air to just break the molten material in the form of droplets and subsequently spray over the surface of the substrate. So, this is how the arc spray unit operates. So, if you just quickly go through the typical variables in the arc spray deposition technique, these are like typical variables are like the arc, the rate at which you are feeding the arc. Usually the rate at which you are feeding the wire for arc generation has to be optimized, because if the wire feeding rate is higher than the rate at which it is consumed, then you will find that there will be no arc which is generated, there will be short circuiting effect. On the other hand, the rate at which you are feeding the wire, if it is lower than that of the rate at which it is consumed, then you will find that the arc will not get generated. So, for generation of perfect arc and subsequently its use for melting of the material, your arc speed has to be, the wire feeding feed has to be maintained or has to be, you can say that standardized, so that there is no chance of any problem related to arc generation. And second parameter is that velocity of the air or inert gas which is used for propelling purpose. So, third parameter is the distance between the arc generation and that of substrate. So, and which material you are using to coat. So, these are few important parameters which play important role for determining the quality of coating, and usually the thickness of coating is in the range of 100 to 2000 micron, and in this coating also powder you can say that coating possesses lot of defects, particularly porosities. So, porosity content varies from 10% to 20% as is there in case of flame spraying. So, a little bit of advancement of this particular technique is the plasma sprayed coating. So, plasma spray coating is a little bit advancement in this regard, that in plasma spraying you get very high heat into the tip of the torch. So, heat content in flame spraying or arc spraying can be 1500 to 1700 degrees Celsius. On the other hand, in plasma spraying it can be as high as 25,000 to 30,000 degrees Celsius. So, in this particular plasma spray coating, what you do is that you basically generate the plasma. Plasma is nothing but cluster of ions and electrons and neutral atoms. So, that particular plasma whenever is generated, then naturally that plasma is having very high energy, and depending on the density of the plasma, basically in this particular plasma you generate lot of plasma densities, lot of ion densities, and because of the generation of very high density ions, your temperature also reaches to a very large level, and basically the plasma is generated in between this copper and tungsten electrode, and as very high heat is generated in this particular torch, you should have the constant cooling arrangement of this particular copper tube. So, proper cooling has to be done so that there is no damage of the electrodes, and that plasma heat is used for the heating or melting of the powders which you are going to coat. So, in that particular plasma zone, you basically feed the material in the form of powder, and then subsequently it is sprayed onto the surface of the substrate. So, this is how the plasma spray operation, plasma spray coating is carried out. So, in plasma spraying, by plasma spraying you can coat any material of your choice because it is having very high melting temperature, but plasma spraying is not applied for the melting of the low melting material, particularly zinc and aluminum, and also you can, if you think of the particularly metallic material having low melting temperature, polymeric material, those materials cannot be deposited by plasma spraying, but high melting materials, ceramic materials, ceramides, they are coated by plasma spraying. So, a little bit advancement of plasma spraying is reactive plasma spraying. So, when you are interested to have metal matrix composite coating or any ceramic coating, you can have metal precursor powder, and you can also flow nitrogen, oxygen as the reactive gas. So, you will find that inside the chamber there will be reaction and then formation of the ceramic particles, metal matrix composite, and that get deposited onto the surface of the substrate. So, this is a very new form of the deposition actually. So, now if you think of the process parameters, this is nothing but nozzle to work distance, then powder size and type, then point of powder introduction, arc current and voltage, types of plasma gas, type of plasma gas which you are using, then particle carrier gas type and particle powder fluents. These are the different parameters which basically play important role jointly to determine the coating quality. Now, if you quickly go through the thermosphere deposited layer cross section, you will find that as I mentioned you in the last few slides, that there are a lot of defects in the coated layer, like oxide particle inclusions, small unmelted particles, and then the splats are basically they are in the form of this molten material are in the form of splats. So, splat formations are always there. So, because of the splat formation, there is also you can say that it is typical pancakes type of structure, and it is not really regular in shape. It is irregular in shape because molten material they strike the surface of the substrate at a little higher velocity. So, it does not remain in uniform shape, it is always having the deformed shape. So, pancake kind of typical structure. So, and in between two pancake there may be lot of porosity formation, there may not be porosity formation, there may be inclusion of the oxide particles. So, those problems are always there. So, if you see the particle substrate interaction phenomena, you will find that at the interface there is always chance of a very thin diffuse layer adhesion at the interface. This is very important, and incipient fusion is also there. Now, if you quickly go through the mechanism of bonding in thermal spray deposition, these are mechanical anchorage, physical adhesion as well as chemical adhesion. So, mechanical anchorage is always there. So, accordingly for all the processes, so you have to prepare the substrate so that there are a lot of grooves on the surface. You usually do it by sandblasting operation. So, that actually gives the anchoring on the, or it promotes the anchoring, as a result of which you will get very high strength in the coating. There is also physical adhesion as well as chemical adhesion phenomena after the spraying operation. So, another type of you can say that a little bit closer to welding process is plasma transfer arc processing. So, where basically the arc passes through the electrical arc current passes through the plasma, and then it strikes the substrate surface. So, plasma is very close to the substrate. Because of its closeness in nature, you will find that molten material get deposited over the surface of the substrate like weld overlaying. So, this is called plasma transfer arc welding. So, you will find that by this particular process you do not really get coating which is like in spraying, because no porosities will be there. Here you get continuous melted layer like you get in cladding operation. So, plasma transferred arc welding process is very much applied for deposition of the clad layer on the surface of the substrate. So, another kind of coating is detonation gun coating. So, in detonation gun coating you basically use the spark plasma, you use spark plug for fuel, for ignition of the fuel. So, what you do is that here actually instead of having the torch for fuel ignition, you can have the localized zone for ignition of the fuel and hence heat generation. So, because you are using the spark plug for heat generation, you will find that this chamber is actually soundproof, very large chamber, and most of the parameters are patented. The material which you are going to deposit this is also patented, and you use the powder in a small quantity, and that small quantity powder, because zone is very low where you generate heat, that region is very low region actually, very small I mean the area of that particular region is quite low, and as a result of which the capacity of its capacity of melting is also quite low. So, by this particular detonation gun spraying process, per pass you cannot deposit more than half a micron thickness. So, where you are interested to deposit very large thickness, there this particular detonation gun can be used, but you have to do it for a long time. Multi-pass coating has to be applied, but otherwise it is very slow process actually. So, this technique can be applied for deposition of the metallic as well as metallic material and metal matrix composite can be deposited, but ceramic material cannot be deposited, because here again you are using oxyacetylene fuel as a torch of heat, as a source of heat. So, your temperature is quite low, it is not as high as in plasma spraying, but here the basic difference between flame spraying and detonation gun spraying is that here as spraying is done in a very low slow rate, and you have to apply several layers of spraying for getting the deposited very thick deposited layer. This particular technique is basically it generates very less stress in the coated layer, and by this particular detonation gun spraying coating you get very dense coating. So, coating density is quite high because the velocity of coating is very high. So, first important advantage of detonation gun coating over that of flame spraying is that this particular coating in this coating rate is quite slow, and you get very thin coating, control is very easy, then there is very less porosity in the coated layer. So, because of the very less porosities in the coated layer, you get very sound coating, and that particular coating can be applied for corrosion resistance application as well as wear resistance application. So, as I mentioned you, temperature is quite reasonably good for metallic and metal matrix composite coating. Particle velocity is very high, above sound velocity. Deposited thickness varies from 50 to 200 micron. Bond strength is approximately 69 MPa, density is 98% of theoretical density, and parameters are spray parameters, fuel gas composition, detonation frequency, firing rate and powder composition. These are the process parameters. These are more or less same everywhere. So, here also the similar parameters are used, but firing rate is very important here, because ignition happens in a very small area inside the typical chamber. Actually, it is not at the outer part of the chamber where you are igniting the gaseous species, where that ignition zone is quite high, quite large actually. Here ignition zone is very small, and as a result of which the firing rate is also quite low, and you have to use very small powder for the coating purpose per pass. So, the last technique is that kinetic spraying technique, where you do not use the heat for spraying operation, but you use basically large kinetic energy for spraying, but powder is usually heated, because if you do not heat the powder, on the powder surface there is always chance of lot of moisture accumulation, moisture absorption. So, you have to take out the moisture out, and usually the material is in the form of semi molten state. So, you do apply this particular gas, you do heat it up using that oxyacetylene flame again to a quite low temperature, and then these powders are basically flowed at a very high velocity by high pressure gas supply and get coated. So, this particular kinetic spraying technique is very easy technique, but it needs special gun because in the as the velocity of this particular sprayed material is higher than that of higher than that of sound velocity. So, there is always chance of the erosion of the nozzle. So, nozzle has to be made of very special material so that it does not erode away because of the spraying operation. So, you should have very tungsten carbide coated or diamond coated tool is used for this particular spraying purpose, and your deposition, you can do any kind of material deposition, but it is better that you use low melting material deposition, like you deposit the aluminum, deposit zinc, deposit nanostructured material, deposit copper. You do not go for deposition of high melting material, because here you are not melting the coating, you are basically spraying it at a very high velocity to get the desired bond strength. So, this is typical mechanism of bonding. For example, copper particles, they are impinged over the surface of the coating, that is aluminum. So, this kind of shape it retains, because you will find that this is at a very high velocity. So, as a result of which mechanical impingement is always there, and it is quite high to a very large degree because of the high velocity, and copper is also in semi molten state, it is not really in solid state. So, it is again get fused into deeply into the molten aluminum. So, you will find that sometimes if the speed is very high at the interface, there is also chance of some aluminide or intermetallic formation or diffusion phenomena. So, if you quickly go through the stages of cold spray deposition process, you will find that it consists of 3 stages, where first stage is that initial time gap required for the coating to be strike over the surface of the substrate and to get impinged in. So, you should give a critical velocity which is around 800 to 900 meter per second. So, below the critical velocity you will find that particles will not get impinged in, it will go out. If it is equal to that of that critical velocity, then it will be remaining on the surface of the substrate, it may erode away the substrate. If it is higher than that of critical velocity, then it will get impinged in the surface of the substrate. So, initial layer will form like that, then there will be second part stage 2, where particle deformation and realignment will be there. So, once the first layer forms, the rest layers will go on forming one by one. Then in stage 3 there is a metallurgical bond formation and void reduction. So, there is always bond formation, because as soon as the first layer forms, then you are not really depositing another material onto the surface of another substrate. Your coating are made of same material. So, you will find that there will be proper bonding, because similar materials come in contact with similar materials, and then finally there will be deformation, bulk deformation. So, in these 4 stages the particular deformation proceeds, this coating proceeds. So, you can apply this thermal spraying for any kind of. Finally, another type of coating is high velocity oxy-fuel coating. So, this particular coating is very much applied for coating of again low melting material, and ceramic material can also be used for coating purpose, but there you have to use very special gun, and in this particular coating, as the name implies, high velocity oxy-fuel coating, here oxyacetylene is used as the source of heat, that burning of oxyacetylene, and then I mean that uniqueness of the process lies on the fact that you basically melt the material, which is not done in kinetic spraying. In kinetic spraying you do not melt the material, material is in solid state in the form of powder, but here HUF spraying your material is in the form of liquid. So, you have to melt it and subsequently spray it at a much higher velocity, higher than that of velocity of sound, and onto the surface of the substrate. So, this HVF spraying is very much applied for deposition of the low melting material coating as well as nanostructure coating. You get very fine grained microstructures after this HVF spraying coating, and can be applied for dense coating. Here density achieved is much higher than that of density achieved in flame spraying, though same fuel is used and same temperature is attained. So, here density is around 99 to 99.5% in contrast to 92 to 93% in case of flame spraying operation, and there is melting of the coating which is not there in kinetic spraying. So, you have to always think of these all advantages and disadvantages of individual technique to know which technique should be applied for which purpose. Now, if you quickly go through the different applications of these thermal spray deposition technique, you will find that these thermal spray deposition techniques can be applied for deposition of a wide varieties of metallic materials like iron and steel, nickel, chromium, cobalt. It can also be applied for coating of the carbides, oxides, then ceramic, then metal matrix composites, ceramates. Can be applied for the deposition of self fusing or self fluxing alloy like nickel, chromium, silicon, boron. Kinetic spraying can be applied for polymeric coating, can be applied for corrosion resistance application like anodic coating zinc, aluminum, cathodic coating stainless steel, tantalum coating, and natural coating like alumina and chromium oxide coating. Can maybe for any application like microelectronics, biomaterials, or polymeric application for improving the non-sticking properties. If you just now we went through all the techniques, now if you quickly go through the comparison of different techniques, you will find that main features which distinguishes each technique from another is that the heat content of the fuel which you are using, and also the speed of the coating. So, if you see these two parameters for all cases, you will find that in plasma spraying the temperature is quite high, and on the other hand in the flame spraying or HVF spraying, wire arc spraying, temperature is of the similar level. Now, if you see the particle velocity, again you will find that particle velocity is highest in HVF spraying, but it is very low in flame spraying, wire arc spraying, or vacuum plasma, or maybe air plasma spraying. Though particle velocity is little higher in air plasma and vacuum plasma spraying, but it is higher than that of flame spraying, but maximum velocity is attained in HVF spraying. So, depending on these two parameters, you will find that density is one variable. Density depends on the velocity of the coating and also the temperature which is generated in the particular coating chamber. It also depends on the for example, if you talk about the kind of coating you can develop, it is very much dependent on the temperature of the nozzle. So, temperature of the particular heat source which you are using. So, higher is the temperature, you can say that there is more probability of the coating of the ceramic coating of ceramic as well as ceramates. So, these things are very important and to consider for the coating of different types of material in practice. Now, future challenge lies on the reducing the equipment cost, reducing the porosity level, interface study is very important, then applications of hybrid processing route is quite important. So, in the next few slides I will say about the different types of thermal spray deposition technique and its applications. Thank you very much.